work based on the national curriculum level descriptors. So level 7, work on number. To estimate rounding to one significant figure. So if we want to estimate the answer to this question, we round each part of it to one significant figure. So we end up with 600 multiplied by 500. And the idea is that we can work this out in our heads. If we can't do this in our heads, then it's not a very good approximation. 6 5s are 30, and the appropriate number of zeros at the end. 946.8 to one significant figure, multiplied by 0.534 to one significant figure. 0.5 is a half of 900, 450. One significant figure, one significant figure. And that is the same as this, and therefore the answer is 30. The whole point of an approximation is that we can do it in our heads. 474 is 500. 34.9 is 30 over 500 divided by 20. So on the top we've got 5 3s are 15 and the appropriate number of zeros, and on the bottom, when you divide, you can appreciate that that is the same as that, and therefore that's 25. We can then cancel by saying 5s into that or 5s into that, but we could then say we'll put that to one significant figure and put this to one significant figure and then cancel at that stage. So we get 1000 as an approximate answer. If we want to make an approximation, correct everything to one significant figure and work it out. To understand the term integer, well, that's all I can say. An integer is in fact a whole number. They're positive integers. These are negative integers. Now if you go from the negative to the positive, we have a problem of the naught, because we can argue that naught is not a whole number, but we do include it in the integer range. So integer is a whole number and it includes naught when you go from negative to positive. To write values as a product of primes. Let's appreciate the word product means multiply to start with, and let's appreciate the prime means the prime numbers 2, 3, 5, 7, 11, 13, 17, 19 and so on. And one way to do it, which is the way I tend to do it, is called a factor tree. We look at the number that we want to write as a product of primes and we say what prime number goes into that. Now straight away, because it's an even number, 2 must go into it, and 2 multiplied by 420 is 840. 2 multiplied by 210 is 420. 2 multiplied by 105 is 210. Now 5 is a prime number and that goes into this. 3 is a prime number and it's 3 7s are 21. So we split our number into prime numbers by this factor tree. And then we can say that 840 equals 2 times 2 times 2 times 5 times 3 times 7. But we might as well put that in order. And we can in fact change that using a little index number there if you require. I have written the number 840 as a product of primes. There's the primes, and product means multiply. That is what the expression product of primes means. Don't think I'll do the other ones well. I think that's an example that will do. To find the highest common factor, HCF, and the lowest common multiple, LCM. So if you want the highest common factor and the lowest common multiple of these two numbers, we don't have to list the factors, but it's easier to see what's going on. So let's list the factors of 12. In other words, all the numbers that go exactly into 12. Now let's list the factors of 18. In other words, all the numbers that go exactly into 18. The highest common factor. Now if we look at 1, 2, 3 and 6, we find that they are in both lists. Therefore 1, 2, 3 and 6 are called common factors. Therefore the highest of those common factors is the number 6. Highest common factor is a factor that goes into both of the numbers, and it's the highest one that does. Lowest common multiple is the lowest number that both 12 and 18 go into. Now one way of doing it is to write down your 12 times table. Problem is, I don't know how far to go for, so I go until I get bored, and then write down your 18 times table and go until you get bored, or in fact until you spot the same number appearing in both lists. So therefore the lowest common multiple is a number that's in the 12 times table, because that's what multiples means, and in the 18 times table, because that's what multiples mean, and that must be the lowest common multiple. Now let's look at that again with larger numbers. We want to find the highest common factor of 180 and 126. Now if we first off use factor trees to work out the product of primes, so we've got 2 times 90, 2 times 45, and 5 times 9, and then 3 times 3, we find out that 180 equals 2 times 2 times 3 times 3 times 5. Now let's do 126. 2 times 63, 3 times 21, 3 times 7. So we've got 126 is 2 times 3 times 3 times 7. Highest common factor. So we've got a 2 there, and we've got a 2 there. We've got a 3 there, and we've got a 3 there. We've got another 3 there, and another 3 there. In other words, common to both of these groups is 2 times 3 times 3. 2 times 3 times 3. So if we work out what 2 times 3 times 3 is, 2 3s are 6, 3 6 are 18, that is the highest common factor. 18 goes into 180, 18 goes into 126, therefore it's a common factor, and it is the highest number that will go into 180 and 126. Now what about the lowest common multiple? Now if 180 is going to divide into this number, then this number must be made up of 2 times 2 times 3 times 3 times 5, because that is 180. If 126 is going to divide exactly into this number, it must contain 2 times 3 times 3 times 7. Well, it's already got a 2 times 3 times 3, and now it's got a 2 times 3 times 3 times 7. So if you multiply this out, which I'm not actually going to do, if you multiply this out, you'll find a number that 180 will divide into, 126 will divide into. Therefore this is a multiple of both these numbers, and it is the lowest multiple of these two numbers. Highest common factor and lowest common multiple. Needs a clear head to get your head round it but once you have, I hope you'd agree it's not too bad.